Okay, cool. So before we jump into our specific quadrilaterals today, because we're going to talk about two specific quadrilaterals, we're going to talk about the quadrilateral family tree. Who of you have seen this in class? Can you let me know? Who have seen this family tree situation before? Okay, and Paul, nice. Oh, lots of people have seen this. That's great. In our other class, not many people had seen it. It was mentioned in passing. Okay, cool. So the quadrilateral family tree is like a way for us to see how all of them are connected, what they have in common with each other, and which ones would be classified as what. Okay, so we're going to chat about it. We're going to talk about some weird things. You're going to be amazed, I promise. All right, let's start with the most basic thing of all. Okay, what do all of these shapes have in common? What is something all of them have in common that makes them all part of this tree? Exactly, beautiful. They've got 4 sides. Okay, they are all quadrilaterals. Okay, remember the word quad means 4. Yeah, beautiful. That's great. The sum of all of their angles will be equal to 360. I love that. So the sum of their angles will be equal to 360 degrees, the same way that the sum of angles in a triangle is equal to 180. That's beautiful. Well done. Okay, cool. Let's try and move through these now. Let's start with this very top one. Now, this very top one stumped our previous class. We landed up calling him Jacob because we struggled to find a name. Who thinks they can tell me what the name of this very top random quadrilateral is? It's not a trapezium. I'm going to put things like that in as we talk. So this one down here, this is a trapezium. Nope. What is his name? Just give it a try, guys. Just see if you can figure it out. What would be the name of this top quadrilateral? Don't be scared to get it wrong. It is quadrilateral. So the second part of its name is quadrilateral. Good guess. But there's something we have to talk about before. So it's going to be something quadrilateral. So trapezoid is actually what the Americans call a trapezium. It's not a word that we use here often. You can use it. It's not wrong. Oh, Gabriella, I really like part of that answer. But I don't love the whole answer. There we go. Chloe swoops in for the win. Okay, this top one is going to be called an irregular quadrilateral, okay? An irregular shape just means that our angles aren't the same, our sides aren't the same. It isn't anything fancy. It's our black sheep of the family, okay? It doesn't have a fancy name. Its name is literally just that it's the irregular quadrilateral. That's it. It doesn't have anything else, okay? There are no properties that would be the same amongst irregular quadrilaterals. We can't say that the sides are equal or parallel or angles are equal. It's just irregular. It is what it is, okay? Yeah, waiting for his glow up. He might have to wait a couple of centuries and have a few descendants for the glow up to happen, but that's fine. Okay. Okay, so then we move into this second level over here. And in the second level, we're dealing with these two shapes, and we're going to be talking about them in quite a bit of detail today. So the one we've already identified is our trapezium. What is this one on the left? Yes, Gabriella. Yes, it is a kite. Beautiful. Okay, do you see how there's no line connecting the kite and the trapezium? Because there isn't anything in common between them other than the fact that they are both quadrilaterals. Okay, so we can't connect them. That's why we're going in these two separate roads from our irregular quadrilateral, because there isn't anything in common between the kite and the trapezium. They are their own people, nice individuals. Okay, so let's have a look at this trapezium. It's already drawn in here. We've got these. Oh, that's okay. If you haven't done anything about irregular quadrilaterals, don't panic. It's just good to know what they are. Okay, so in our trapezium, we've got this pair here of parallel lines, which is important for us moving forward. And then you'll see that we have an arrow that connects us down here. And then all four of these quadrilaterals down here are connected to each other, which means they all share something in common with this trapezium. What do they share in common with this trapezium? What do they share? That's the same as the trapezium. All four of those down there. Have a look and see what the lines are saying. Good, parallel sides. Good, okay. So the same way that our trapezium had those parallel sides, all four of these have got that same set of parallel sides. Beautiful. Okay, so that's what all of those have in common. That's why we can connect them to the trapezium. Okay, then you'll see that we've got a line that connects the kite to this shape down here. What is the shape that my kite is connecting to? What is its name? Yes. Guys, you're so smart. Good. It's called a rhombus. Yes, absolutely. What does the kite and the rhombus have in common? What does the kite and the rhombus have in common? Why are we able to draw that line? Two sets of equal angles? Sides, there we go. Okay, do you think you can tell me the word I'm looking for here? So I'm not looking for opposite sides are equal. I'm looking for another mathematical word about sides being equal. So something sides being equal, but not opposite. Adjacent, yes. So remember, adjacent means next to. So those two sides are adjacent and they're equal to each other. And in our rhombus, this is equal to this. And then in our kite again, that side is equal to that side, again, adjacent sides. And in our rhombus, that's equal to that. It's just that all of them are equal. So that's what they have in common. Okay. Yes, nice, beautiful. Okay, so we've got adjacent equal sides. Let's jump into our middle shape over here. What is the shape just under our trapezium called? You guys are ready. That was so fast. A parallelogram. Okay, remember you can also call a parallelogram a palm, and you can also write it like this. So you can draw the parallel lines and then write gram, because that's saying parallelogram. Both of those are fine. Beautiful. Okay. Nice. What is the shape down here? The one that's to the right of the parallelogram. Yes, good. Okay. And our last most special shape is a square. Okay. I'm going to ask you a question now, and I want you to vote. Okay. So you're going to be saying yes or no. My question to you is a square a rectangle? Is a square a rectangle? Yes or no? Give me a vote. Yes or no? Square's a square. Oh, we already have one yes so far. I'm very curious. Okay. Kwezi, tell me your thoughts.
No, ma'am, it is not a rectangle.
Why?
Because, ma'am, a rectangle has two opposite sides that are equal.
Okay,
and a
but
square,
wait, no, slow down. You said two opposite sides that are equal, right?
Yes.
So that side's equal to that side, and that side's equal to that side. Isn't that two opposite sides that are equal?
Yes, ma'am, it is.
So is a square a rectangle?
No. No, ma'am, it's not.
Okay, so I am trying to trick you, but I'm also not trying to trick you. Don't hate me when I say this, but a square is actually a rectangle. A square is a specialized rectangle. A square is like it's a special rectangle because it fits all of the criteria of a rectangle, except that it's just not that. But a rectangle, this is where it gets messy. So a square is a rectangle. Leah, you absolutely saw it, and it was beautiful. A square is a rectangle, but a rectangle is not a square, because a rectangle doesn't have the same qualities that a square has, because one of the qualities of a square is that all of the sides are the same, and a rectangle doesn't have that. So a square is a special rectangle, but a rectangle is not a square. Just so you know, you don't know, this could come up in a like quiz down the line, and you're going to be so happy that we had this conversation, and you're going to be like, you know what, I know the answer to this ridiculous question. But yes, a square is a rectangle, but a rectangle is not a square. And the reason we can say that is because a square fits all the properties that a rectangle is, except that it's going one step there's my load shedding. It's going one step further and saying all of the sides are equal. Okay. All right. Let's just talk about these quickly. So your rhombus and your square, they also share a lot of things that are the same. The only difference between a rhombus and a square is that a square has got 90 degrees and a rhombus does not have 90 degrees. And so I like to think of your rhombus and your parallelogram as your drunk relatives. So your rhombus has had a little bit too much beer, falling over a little bit. So he's a square that has fallen over. And your parallelogram is your drunk rectangle. It's also had a bit too much beer, and he's also falling over a little bit. So they have all the same properties otherwise, except for the fact that they're not at 90 degrees. Okay, but hopefully by seeing it like this, you can see how everything is connected. You can see that your square is actually your most specialized shape. You can be quite sneaky and actually say a square is also a rhombus, but we can get back to that. Yeah. Okay, cool. Nice. Let's have a look at these two shapes that we are going to be talking about today, now that I have confused you horribly. We are going to be focusing on the kite and the trapezium. These are the two shapes we're going to talk about today. All right, so some of it we've already spoken about. We have got in our kite, we have got our adjacent equal sides. So that side is equal to that side. And oh my goodness, my lines are getting worse as the night goes on. That side is equal to that side. So those are our adjacent equal sides. Now what I'm going to do is I want to know one other thing. There's lots of other things you could tell me, but can you tell me one other thing about this kite? One other property about it? Square is a sober rhombus, absolutely. So there is a 90 degree involved if we draw in our diagonals. So if we draw in our diagonal 1 and diagonal 2, then we have 90 degrees that are involved. Yep, so our diagonals bisect at 90. One set of opposite angles, yes. This angle here is going to be equal to that angle over there. And the reason that they're equal is because they are congruent triangles, which is what we're going to talk about on Thursday. Nice. Okay. So that's our kite. And we're going to be talking about it just now. And then we've got the shape at the bottom, which is our trapezium. And the trapezium is super boring because it's just that this side is parallel to this side. This is a trapezium. Okay. Who thinks they can tell me? No, you've got your quiz on Thursday. Who thinks they can tell me a very normal mistake that people make about a trapezium? So kind of look at the shape and say something that you think is there, but it hasn't said. Write your suggestions down in the chat. So sometimes, yes, sometimes people can mistake it for a rectangle, but then we remember that they aren't the 90 degrees. Something about the angles. Yes, good. So often people make two mistakes. Sometimes they think that these two sides are equal to each other. Sometimes they can be equal to each other, but they have to tell you that. And sometimes people think that these two angles are equal to each other. And again, they can be, but we have to be told that. So if we're not told, we can't assume that. If we have a trapezium that looks like this, okay, and we're told that this side is equal to that side, it's actually got a fancy name. It's called an isosceles trapezium. And if you think about it, that makes a lot of sense, because if you think about an isosceles triangle, it's a triangle where the two sides are the same. This is the same situation. So it's a trapezium where two sides are the same. But then they have to tell you that. Okay, so you can't ever just assume that that's the case. And if it's an isosceles trapezium, then those angles would be the same as each other, but only if it's an isosceles trapezium. Okay. Does anyone have any questions about anything we've spoken about so far before we jump into a few questions? We're going to do a couple examples, some nice easy ones, and we'll take a brain break and do a trickier question after the brain break. No questions so far. Please don't feel scared to ask. Okay. All right. So we're going to start with this very first question over here, and we're going to talk about a couple of ways that make geometry questions easier. The first thing is by breaking it up into sections. So literally just read one question at a time and fill in what you can. Okay, so let's read. It says, consider kite A, B, C, D. So A, B, C, D. This is my kite. Before we read the rest of this question, what can you tell me about this kite that you've already told me? You told me earlier. So what can you tell me about this kite? What can you tell me about the sides? The adjacent sides are equal. Okay, how could we write that as like a mathematical sentence? Because we're going to need to put it over here. So how could we write that? Yes, we can put that as our reason. So adjacent sides of a kite are equal. What would my sentence look like? There we go. Okay, so we're going to say AB is equal to BC. So we're saying those two lines are equal because adjacent sides of a kite are equal. Let's also, we won't need it for this question, but let's also put in these ones. Actually, maybe we will, because I might add a couple of questions here. So we're going to say AD is equal to DC. And again, we're going to say because adjacent sides of a kite are equal. Okay. Cool. Remember, in geometry, whatever you put in your diagram, you have to also write. You have to tell me what you're doing. Okay. Now let's read the rest of this question. The first thing, we're actually going to do it slightly differently because I think you guys are a little bit too bright. We are going to get rid of this. Ooh, that's fun. Yeah, exactly. Like giant typics. I want you to find X. I want you to find Y. What else do I want you to find? Let's start with X and Y for now. Don't forget your reasons, guys. Benjamin, look at that beautiful reason. Yes. Okay, I'm seeing lots of people are starting with this, which is great. So X is definitely equal to 50 degrees. And our reason is if you write angles opposite equal sides, it's fine. I like to write equals before, but you don't have to. Equal angles opposite equal sides. Beautiful. So that's our 50 degrees. Now we know that that one's 50 over there. Yes, nice. Okay, so Y is going to be equal to 180 degrees minus 50 because of sum of angles in a triangle, which means Y is equal to 80 degrees. Can we say vertically opposite angles? You can't say vertically opposite angles. You can only say vertically opposite angles if there's an X. So like if that was 97 degrees, and that's why you could say Y is equal to 97 because of vertically opposite, because there's that X, but we don't have that X. So Michael, absolutely, just make sure you write the whole reason. So angles opposite equal sides. Don't forget your reasons, guys. Your reasons are so super important. Okay, please feel free to take a screenshot of this question. Does anyone, and please don't be nervous, and you're welcome to send a direct message to me if you're feeling embarrassed. Is anyone needing to get more clarification on what we've done in this question over here? Or feeling a little bit lost or not understanding where any of the numbers are coming from? Okay, Kwesi, where are you feeling confused? Talk to me. Can you pop your hand up so I can unmute you? Hello?
Hello, ma'am.
Okay, tell me where you're feeling lost.
Ma'am, for the first two answers, how
Yeah.
did you get it?
So the A, B, the red line and the blue line.
Yes, ma'am.
Okay, so that's the reason we can write those is because we know that this is a kite. And because it's a kite, we know that those two lines would be the same and those two lines would be the same.
Oh,
So we're
okay.
using like our knowledge of the properties of a kite to write those first two lines.
Okay. Thank you,
Okay,
ma'am.
no problem. So DC is the same. We know that DC is equal to AD because of the fact that it's a kite. Good. Okay, nice job, guys. Let's jump into a second question. You guys are very clever though, so I'm wanting to actually not help you so much with this question. I think what I'm going to do is I'm actually going to let you figure this one out a little bit first before I give you any help. Try and remember the things we spoke about, though, about breaking this question up into small pieces. Is this a kite? Are we reading the question? The first thing we got to read is read. We got to read. Yeah, and Disa, I will pop up back for you just now. Try and read each sentence. I would draw this. If you've got a piece of paper at home, just quickly jot this down because it'll be much easier to do on a piece of paper than trying to look at it on the screen. And I will help you because I know sometimes this can be tricky. Instead of saying ACD, I want you to find X. And before you tell me there isn't enough information in this question, I promise you there is. So AC is a common side, but we would only use common sides when it comes to congruency or similarity. And we aren't doing congruency here. Yes, ABC is definitely an equilateral triangle. Think about what that means. Good, good. Oh, you know, our first answers then. It's very exciting. I haven't seen the right answer yet, but that's okay. I'll make this angle here Y for those who are needing it. You don't have to use it. There are more than one way to do this question. Ooh, lots of different answers popping through. Okay, okay. I can tell you that X is definitely not a very, very big angle. I'm trying not to give away the answer. I do see you asking if it's correct. Y is definitely not equal to 0. Okay, I'm going to slowly go through this question and sort of talk about it step by step. And then you'll be like, oh, that makes so much sense. Okay, this is telling us that ABCD is a trapezium. ABCD is a trapezium, which means that this line, gosh, guys, I keep on thinking my lines can't get worse, and then they do. This line is parallel to that line. Okay, so that's what the first part of the question is telling us. That's what we needed to get from it. Okay, because AD is parallel to BC. Remember that those two lines there, that means parallel. Okay, next part of the question was telling us that ABC is an equilateral triangle. Okay, so this triangle over here is an equilateral triangle, and that means that all of my sides are the same as each other. So all of my sides are equal. The side's equal to the side, which is equal to the side, and all of my angles are equal to 60 degrees. Okay, I'm going to write that in my sentence so far. So I'm going to say over here that angle A is equal to angle B, which is equal to angle C, which is equal to 60 degrees. And my reason for that is equilateral triangle, if you want to. Or you could say sum of angles in a triangle. Both of those are fine. Oh, I hadn't read the question. Famous last words. It's okay, I still love you, but to read the question. Okay, lots of different ways to do this next thing. But as soon as you see that there are parallel lines, your mind needs to jump to fun. You need to look for those letters and see which one can help you. Okay, so I can't get an F in this current situation. Let's see if we can get a Z or an N. And if you have a look here, this line to this line to this line, there's a Z, right? Which means that Y is going to equal 60 degrees. So we can say Y is equal to 60 degrees because alt angles are equal when AD is parallel to BC. So now we know that this is 60. If we know that that's 60, now finding X is a lot easier because we can say X plus 60 plus 22 needs to equal 180 because of sum of angles in a triangle. So X plus 82 equals 180, which means X is equal to 180 minus 82, which is equal to 98 degrees. And lots of people got to that answer, which made me really, really happy. Did anyone do it a different way? Did anyone not use alt angles? Did someone use a different way of using those parallel lines? Because you didn't have to do alt angles. You could have done it in one line. I'm just curious. That's fine. If you did it like that, that's great. The great thing with geometry, there's always more than one way. Not always. Let me not say always. There's often more than one way to do it. So if we have a look here, that line's parallel and that line's parallel and that line's connecting it. That's our transversal line. So it's actually a U. And so we could have said that these angles plus this angle needs to equal 180. So we could have said 60 plus X plus 22 is equal to 180 because of co-interior angles. And then you would have gotten the same answer. It's just always good to see different ways to do it. Okay. Please feel free to take a screenshot, and then I'm going to quickly pop up to the previous question because I have someone else who needed a screenshot, and then we are going to jump into a brain break. You forgot about fun for a little, that's okay. Okay, just going to pop back up to this one, just for anyone who didn't get a chance to get the answer. Michael, I also love geometry. Les, I won't be able to start this one from the beginning again just because of our time, but remember these lessons are recorded, so you can always watch it again. Yes, I can, Tato, I can absolutely hop back up to the family tree. It's quite messy, but here we go. Here's our quadrilateral family tree. Well, technically, equations are part of geometry. So if you like algebra, you kind of like geometry. Okay, brain break. I'm excited about this one. I think it's a cool one. Okay, so you're only allowed to move 3 coins. And in moving those 3 coins, you would be making this an upside down triangle. I'm open for suggestions. Okay, Vuya, can you help me?
Ma'am, can't you just move the middle 3, ma'am, to the bottom, ma'am, and then just
these 3 here.
Yes, ma'am.
But then what's going to happen with this top chart, this top one?
Ma'am, don't you just slide the rest up, ma'am?
So are you can you tell me how you want me to move these?
Ma'am, like you take all three of them in the same formation, ma'am, and then just move them down.
You want to move them down. So like 1, 2, 3.
Yes, ma'am. But in the middle, ma'am.
But if they're in the middle, then they won't be in the same place. So
Okay,
I hear what you're saying. No, I hear what you're saying though. So like if I move those ones, it's good. It's a very good start. It's not the right answer, but it's a good start. So if I move those here, I'd have 1, 2, 3, and then I wouldn't, let's say we moved those 3 instead of this middle one, but then I still wouldn't have a triangle.
Okay, ma'am.
But it's a good start. Let's see. CM Tanda, can you help?
Yes, ma'am.
Okay.
All you have to do is take the top one, put it at
Yeah.
the bottom, and then take the bottom 2 on the left and right and put them in the second from top.
Okay, so let's talk this through. So you want me to take the, oh no, I think my screen has frozen. Oh no, it's back. Okay, stress there for a second. Okay, so you want me to take the top one, and where do you want me to move it?
Move it to the bottom, ma'am.
Move it to the bottom. Okay.
Yes. And then take the
Next.
bottom 2 from the right and the left. And
Okay.
then move them to the second line from the top.
So to here.
Yes, ma'am.
Yay! Nice job. There's our beautiful triangle. Woo! How did you solve it so quickly?
Well, all you have to do is just try and refigure it, ma'am.
Nice. Good. I'm very proud of you. That was really great. That was so nice and quick. Nice job, guys. Okay, I'm going to quickly erase this for you guys in case you're wanting to torture your parents with it. And like I said to the previous class, see if you can get some chocolates out of them. Tell them if they can't solve it in 2 minutes, you got to get you a chocolate or sweet. You're just going to have to remember the right answer in case you have to help them out. Nice job, Lo. Okay, let's jump to our slightly harder questions. I'm going to do the same thing I did with the last one. I'm not going to help you because I think that it was good that you were able to give things a try. I'm going to write some letters in just to make it easier for working out on your part. So we're going to call, oh my goodness. My laptop is tired. Let's say X, Y, Z, W. I'm trying to think of which letters you might want to use. I'll just call that A, B, and C, D. You definitely don't need to use all of these angles. I'm just putting them there so that they're there to help you. Remember to read the question. Read the question. Yes, my love, how can I help?
Hi, ma'am.
Hi.
How are you, ma'am?
I'm very well, thank you. How are you?
Very good, ma'am. I'd like to answer this question for us, ma'am.
Okay, can you start with the first part of it?
Okay, ma'am. So I'm saying that X will equal 50, ma'am.
Okay,
because
good.
angles are in a straight line.
Nice. Angles in a straight line. Beautiful. You know what? Actually, I'm gonna hold you for like 2 minutes just because I want the other people to catch up. So I'm just gonna mute you, but I'm gonna come back to you as soon as I've given everyone a chance. Okay. But I promise I will unmute you in like 2 minutes. Was that the fastest brain break? It's because it was solved so quickly. I'll make sure the brain break we have on Thursday is very tough so that you can't solve it. Okay, just to help out what we have done so far. Keep on trying. Okay, we're all yours. Keep on going.
Okay, ma'am. Since we figure out what X is, then we can figure out what A is, ma'am. So all we
Okay.
have to do is calculate that, ma'am. And let me just calculate, ma'am. I'm saying. Yeah, A is 63, ma'am.
It is. Do we need A?
Not really, ma'am. Wait, let me see this.
Which letter are we
Actually,
looking
yes,
for?
ma'am, we do need it because I would say because HE is parallel to KF,
Yeah.
so it would be alt angles equal.
Okay, keep on going. Okay, so A is going to be equal to
63, ma'am.
okay, so let's write this equation. Okay, so we're gonna say A plus 67 plus 50 is equal to 180. Sum of angles in a triangle.
Yes, ma'am.
Okay, so A is equal to 63 degrees. Beautiful. Okay, guys, there's lots of other ways to do this. If you've done it in a different way, I'm very keen to hear how you've done it. Okay. All right, keep on going.
So, ma'am, I could go to Y, ma'am, but like Y equals 50.
But do we have to?
I mean, ma'am, it's just all the letters, ma'am. You know what I'm saying?
So if we only need to find that angle, we're only looking for.
But I mean, ma'am, okay, we can do D, right? D is also let me see this. D is 113, ma'am.
We could absolutely do D. Do we need to do D?
Okay, ma'am. Okay.
You've done
actually,
everything.
Yes.
You're
Yes,
making your
ma'am,
life harder than you need to. You've done everything you need to do. You can jump straight to the answer now.
Oh, ma'am, I didn't read the question.
You silly banana. Read the question.
So W equals 63, ma'am.
Why?
Because of alt angles equal, ma'am.
Beautiful. Trying to make your life so hard.
I don't know, ma'am. Yeah.
Nice job, though. That was brilliant.
But
Nice
I mean,
job.
ma'am, because like.
Oh, I didn't. Sorry, I muted you by mistake. You can unmute yourself. There we go.
So you see, ma'am, because you put out all these letters, I was like, oh, let me just solve all the letters, you know, ma'am.
I was just trying to help in case people were struggling with the weird ways of doing it.
Okay, ma'am.
But nice job. It's always good to do more. Okay, I'm seeing lots of other ones here, which is cool. Did anyone do it a different way? So did anyone not do it this way where we did the alternate angle? I'm just curious. Was doing a long way, that's okay. Did anyone like start by finding why? No. It's so interesting. So when like everyone, the cool thing with geometry is that like people see different things, like and that's how it works. When I did this question, I first solved y, and then I used this alternate angle to get z, and then I was able to find w. That was how I solved it. But both ways are great. It doesn't matter. Get to the same answer, which is cool. Yeah. Okay, take a screenshot if you would like one, guys. We can quickly pop in one more question, I think. So we've got a little bit of extra time. The next question is quite tough, if I remember. We might not get through the whole thing, but we can try. Okay. Okay. EFHG is a parallelogram and EFJH is a rhombus. Okay, and they're telling us that this angle here is 44 degrees. They're also telling us we're dealing with a straight line. That just helps us to know which ones would be equal to 180. And we are having to solve. So FHJ is this angle over here. I'll put an X there for you. And FEG is this big angle over here. So it's including that whole thing. Those are the two angles we're trying to solve. Let's see if we make any progress. I'll put in numbers for you. So like E1, E2, H1, H2, H3, F1, F2. That's such a good start. E2 is 44. Well done. That's a really good start. Nice. Remember, the key with geometry is to see what information have they given you and like use that. So we can see that J is 44. What else could be 44? That's a brilliant way to start this question. Nice. H1 is 44 because of corresponding angles. Yes. Ah, you guys, beautiful. Okay, so we can see that this is 44 because we're dealing with opposite sides of our rhombus over there. And we could see that this is 44. You could either say corresponding angles or you could say alternate angles. Both of them would be fine. It's a great way to start. I think a very important thing to keep in mind here, which I think as soon as I draw it, you're going to be like, oh. Oh, sorry, guys. Okay, EFJH is a rhombus. EFJH is a rhombus. Okay, and if it's a rhombus, it means that all of our sides are equal, which means this side equals that side. What have we created? We've created an isosceles triangle, and this side is equal to this side. We've created an isosceles triangle. Just keep that in mind. It might help you. Yeah, 44 plus H2 plus H3 definitely would equal 180 degrees completely. Are we going through a bunch of quotes on Google now? Yes, Palesa, how can you help me?
Ma'am, I think H2 is equal to oh no, it's not what I thought it was.
Okay, that's okay. What were you going to say?
I was gonna say 44 degrees.
It's not going to be 44, but I'll show you why not. Okay, so if we're looking at that triangle, if this is an isosceles triangle, we know that this angle and this angle are the same as each other because it's an isosceles triangle. So we can say angle F1 is equal to angle H2 because of angles opposite equal sides. Okay, we should have, oh no, they told us it was a rhombus, so we're okay. And then we could say, therefore, F1 is equal to H2, which would be equal to 180 minus 44 divided by 2, sum of angles in a triangle. And that would be equal to, I think it was 68. So then we know that this one's 68, and we know that this one's 68, and we know that this one's 68, and we know that this one's 68. Actually know a lot of information for that. If we know that that's 68, are we able now to find E1? Or can we find this whole angle? Can we find the angle E? Okay, so we were able to say that E was 44 because they were opposite sides, opposite angles of a rhombus. And H1 was 44 because they were corresponding angles. We should put those in there. Yeah. So now we've got lots of different options. You could be working with your opposite angles of a quadrilateral. So you could say that therefore this would be 68, and then we could see what that would be equal to. You could use alternate angles here. You could also have used co-interior angles. You would have had so many different options. But basically, I'm just going to write down one option over here just because we're drastically running out of time. So I'm going to say E1 is equal to 68 degrees because alt angles are equal when EG is parallel to FH. And therefore, angle E is going to be 68 plus 44, which is going to be equal to 112 degrees. Well, I'm glad that you didn't find it hard. That's awesome. Good. Please feel free to take a screenshot. I know it's quite messy. I will pop up to the question above so you can go take a photo, and then don't go anywhere because you got to do your pace poll with Simone, and I will see you guys on Thursday for congruency. I'm going to quickly pop up here so you can take a screenshot. I'll show you now how those angles are corresponding. So we've got, for everyone else, just fill in the pace poll and then you can be on your way. Have a beautiful evening, everyone, and I will see you on Thursday. That's the F. And so this angle here would be equal to that angle there.